Okay, here we go. All right, so guys, yesterday we did section 2.2. I give you 1 day. That's it. 1 day, identify a linear equation from a nonlinear equation. Nice and easy. We're going right into section 3 now. Section 3 is all about graphing linear equations. However, I can never bring myself to go into graphing before I review something first, and you'll see what that something is in a minute. So we have to kind of pump the brakes on graphing. I want to review a different topic first. So guys, look at your warm-up. I've given you the graph of a straight line. So is that a linear graph? Absolutely, right? Guys, now that we know what a linear equation is, what he looks like, how he behaves, now we're just going to work with them. So now everything I give you from this point on will be a linear equation, all right? Okay, so I asked you to look at this line, and I asked you how many spaces up do you have to go to get from point A to point B? So here's point A, and here's point B. I asked you how many spaces do you have to go up to get to that where that next point is? 3. And in math, we call up a positive movement. So we would call that a positive 3. So you have to go up 3 spaces. Okay. Then I asked you, how many spaces to the right do you have to go to get from point A to point B? So how many spaces to the right did you have to go? 2. So now that's how we get from one point to the next on this line. We have to rise up 3 points and we have to run over 2 points. Does anybody know what you just found of that line? Which is called you have just found the slope of that line. All right, and now that you're in big bad algebra 2, that is known as the rate of change. How this line is changing from one point to the next. And the reason that a linear equation makes a straight line, the reason why this line is straight is because that slope, that rate of change is always the same between any 2 points on this line. So guys, look at the next one. If this was B and this was C, how many spaces do you have to go up to get to the next point? 3 again. How many do you have to go to the right? 2, because on a straight line, the slope is always the same. That rate of change in between 2 points is always constant. It's always exactly the same. Look down here. If I went to go from this point to this point, how many do I have to go up? 3. And how many do I have to go over? It's always the same. That's why lines are straight, because they have a constant rate of change. A linear equation only gives you one rate. It only gives you one average rate of change, one speed, if you will. Because guys, if they didn't have the same rate of change in between all points, let's say to get from this point to the next point, you only had to go up 1 and right 6. Now the line would do this. Is it straight anymore? No. If you had a different rate of change in between points, then your line wouldn't be straight. All right? So this is why linear equations have a straight line. They have this constant rate of change, this constant slope in between any 2 points on it. All right, perfect. So that's what I want to review today is before we go into graphing, I like to review slope with you. I like to make sure we all know who he is, how we find it before we use it very, very much when we start graphing. So we're going to review slope, and then we'll get into the graphing next week. All right, so let me give you your notes. Hopefully this will be easy and a review. We do have homework, but it's not bad. It's on down to math. You get 2 tries again. Guys, I'm my black marker is not making it for the rest of the day. Is the red bothering anybody? Are you guys okay? It pains you? I prefer the black too, but
anything but red.
I know, I'm telling you, you're just messing with me. It's working. My dad would be up here saying, what the heck are you writing up there? All right, here we go. So guys, I hope you remember slope from Algebra 1, so I know you guys cover it a lot. But I tend to teach it like you've never seen it before, so please bear with all of my definitions and stuff. Okay, so like I said, we're starting section 3, which is going to deal with the graphs, but not yet. I want to review slope first. All right, so we saw yesterday in section 2 how to find out whether an equation or function is what we call linear. We saw that if you are a linear equation or function, then you are a degree 1 equation, which means The highest exponent on any variable is who? 1, right? You don't got to deal with any x squares or x's to the third or x's to the fourth. This is just good old x and good old y. It is a degree 1 equation that can be written in the form y equals mx plus b. It's everybody's favorite math formula. You guys always remember that one. Okay. Then we also saw that if you are the graph of a linear equation or function, then your graph will always be a straight line. And the reason why the lines are always straight is because a linear equation has a constant rate of change. The rate of change between any 2 points on the line is always the same. You just saw it on the warm-up. That line was straight because the rate of change in between any pair of points was up 3 and right 2. That was its rate of change. That was its slope. And a linear equation will only have one rate. It will only have one slope. All right, and that rate of change is known as the slope. So guys, now that you're in Algebra 2, they don't always call it slope. Sometimes they'll say, find the average rate of change. And that is slope. That is what slope is. He is a rate of change. Okay, the slope of a line measures the rate at which a line is changing. Basically, the slope is measuring the steepness and the direction. Is your line rising really, really fast? Or is your line rising really, really, really slow? The slope will tell us. Is your line falling really, really, really fast? Or is your line falling really, 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 really slow? The slope will tell us. That's what the slope is measuring. It's measuring the rate at which it's changing, okay? Where am I now? Oh, I gotta move it up. Okay, so how does slope find this rate of change? By his definition, the way slope was defined when he was first created years and years and years ago. Slope finds this rate of change by comparing how fast a line is moving up or down compared to how fast it is moving left or right. You have to find the vertical change and compare it to its horizontal change. That's how we measure slope. It's a fractional comparison as to how fast the line is going up or down compared to how fast it's moving side to side. That is slope. Okay, compare the vertical change to the horizontal change. Okay. Okay, so this rate of change, this slope, we usually always use the variable m to represent the slope. So if we're going to find this vertical change compared to its horizontal change, then you have to find the change in the y, the up and down movement, compared to the change in the x, the side to side, the horizontal movement. So we say slope is the change in y over the change in x. So hopefully this is all bringing back memories. This is usually the number one problem I find students have with slope, is they're like, God, why is it got to be y over x? X comes first in the ordered pair, so why can't x go on top? And the only thing I can tell you guys is because that's not how they defined it. When they created slope as this rate of change, they defined it to be the vertical change over the horizontal change. The change in y over the change in x. So try to remember that. Okay. So if we're looking at a graph, great, we'll just count the spaces. How many up or down did I have to go? How many left or right did I have to go? It's great. But if you're not looking at a graph, then you're going to have to calculate that change on your own. So guys, if you want to find the change in something, what operation do we use in there? Subtraction, right? Like if the temperature went from 75 degrees to 70, how would you find the change in that? You would subtract the two temperatures. So if you want to find the change in your y coordinates, you have to subtract them. If you want to find the change in your x coordinates, bless you, you have to subtract them. So normally, they either give you a graph or they give you points. They can give you point 1, x1 and y1, and they can give you point 2, x2 and y2. And then when you want to find the change in those coordinates, you'll subtract them. So normally they tell you to take y2 and subtract y1 to find the change in your y's. And then they tell you to take x2 and subtract x1 to find the change in your x coordinates. Now listen, I always put this up here, and I don't mean to confuse anybody. I just want you to know that it's okay. Normally, a math book will define it y2 minus y1 over x2 minus x1. But guys, at the end of the day, it doesn't matter which point you start with. If you go from the first point to the second point and find the change, you're going to end up with the exact same slope as somebody who started at the second point and went to the first point. So it's okay if you did y1 minus y2 over x1 minus x2. It's okay. You're going to get the exact same slope. All right, I tend to do this because I feel like that's how you've been trained in Algebra 1, but it is okay. The only thing you can't do is you can't do y2 minus y1 in that order and then go x1 minus x2 in the reverse order. You can't do that. Once you've picked an order, you got to stick with it. Okay, and then these always help me. The change in y over change in x, the two R words that help us remember that is that it's always the rise over the run. All right, and I always think, guys, rise, wise. They rhyme. Rise, wise. They're on top. Okay, let's give it a go. So, guys, there's 3 ways they can ask you to find this rate of change, this slope. Number 1, they can give you a graph. We're going to do that first. Then they can give you points that would make up a line, and you can calculate the slope on your own. And then they can turn it into a word problem. So I'm going to save the word problems for tomorrow. Today we're just looking at graphs and points.
Marty, are you recording?
I am. I think I am. But thank you. You gotta do that. Don't not ask me. Okay. Let's do it. Nice and easy. Let's find some slopes. All right. So here's the first graph. We have to find the slope, the rate of change of this line. So guys, pick 2 points. I advise you to pick consecutive points. If you pick these 2 points, you can do it. That usually means you're going to have to reduce your answer. So to try and avoid reducing, I'm not saying you can always avoid it, but to try and avoid it, try to pick consecutive points on the line. All right, so guys, I'm going to choose to find the slope going from this point to this point. Because remember, it's a straight line. It's the same slope in between any 2 points. So just pick 2 and go with it. All right, it's rise over run. So you have to do up or down first. So guys, do I have to go up or down to get to the next dot? Up how many spaces?
I don't know.
You got to count. Like right here, right now we're here. So we'd have to go 1, 2, 3 spaces up. And in math, up is a positive. So that would be a positive number. So we went up 3. So my rise number is positive 3. And then my run is how many did I have to go to the right to get to the next dot?
4.
I got 4. I got 1, 2, 3, 4. So right 4, would that be positive or negative? Positive. So now my run number, bless you, is 4. So the slope of this line is 3/4. It's saying for every 3 units you go up, you go to the right 4. And that's how you move along the entire line. Up 3, right 4. Up 3, right 4. That is the rate of change in between every single pair of points. All right, now, just to put this out there, we're not always going to pick the same points. So maybe somebody said, Hardy, I didn't do it that way. I found the slope by going from this dot to this dot. Great, okay. So sometimes it's going to look like there's a different answer. But guys, every line only has one slope. There might be different ways you can write it, but it's all the same. So guys, if somebody went from here to here, would they have to go up or down? They had to go down. How many? Down 3 would be what number? -3. So you'd be like, oh, my slope's already different. And then they had to go, how many to the left? 4, which is -4. So this one says for every 3 spaces you go down, you go to the left 4, which is true. It's the exact same line. But guys, at the end of the day, it is a fraction, and you have to reduce it. And what is a negative? Always reduce to. So we'll always end up with the same answer, even if it doesn't look the same once you get it. All right, next one. Let's find the slope of this one. So guys, this is pretty steep. Look at it. Let's see what we got. Pick 2 points and find the rise over the run. How are you getting from one dot to the next? I'm going to live on the edge, and I'm going to go from this dot to this dot this time. Do I have to go up or down first? Down, because you always want to do your rise first, because that's the top number. So now I had to go down how many? 4. What's down 4 as a number in math? That's -4. And then I had to go to the right, how many spaces? Right 1, which would be +1. So now this slope is for every 4 spaces it drops down, it goes to the right 1. So guys, this is a pretty steep line because it's dropping 4 and, only moving to the side 1. It is rising or falling much, much faster than it's moving side to side. It's dropping 4 times faster than its horizontal change. So that's why it's so steep. Okay, at the end of the day though, what does -4 divided by 1 reduce to? -4. So I would put -4 as my final answer because Delta Math is going to mark you wrong if you don't reduce. And I don't know if Delta Math considers that reduced or not. I mean, you might not be allowed to put the 1 there. I don't think they should mark you wrong, but I don't know. And again, just to give it discussion, guys, if somebody went from this dot to this dot, they have to go up 4, which is what? Positive, and they have to go left 1, which is what? So somebody might say, well, I got that slope. Guys, it's the same thing. What's 4 divided by -1? It's -4. Remember, a fraction doesn't matter who has the negative sign, okay? All right, so it is -4. All right, perfect. Do you all hear that?
Yeah, what is it?
Is that my pump? No, right? It's in here. I'm having so many pump issues today, guys. My blood sugar was over 500. I feel like crap. We're fine. You're supposed to be around 90, 99. Yeah. The life of a diabetic is fun. You know, my pod expired in my sleep last night, and I didn't know it. And then when I woke up late this morning, I couldn't change it. I had to change it at lunch today, and I went about probably 6 hours without insulin. Very bad. Very bad. And you're just all right, I'm getting there. I feel not a lot better, but we'll be there. All right, so then I consider this your special cases. Guys, a straight line can really only do 4 things. It can either slant to the right, we call that a rising line. It can slant down to the right, we call that a falling line. It can either be horizontal or it can be vertical. That's the only 4 things a straight line can do. So I always consider your horizontals and your verticals as special cases of straight lines. Because you'll see when we go in section 4 and we start writing their equations, we handle them a little bit differently. So I always think of them as special. But either way, we can find their slope. All right, the slope of this one. Rise over run. Change in y over change in x. Guys, if I go from this dot to that dot, how many did I have to go up or down to get to the next point? 0, I didn't. There's no rise on a horizontal line. It doesn't go up, it doesn't go down. It's flat. There's no rise. Over, not that it really matters, but then I have to go how many to the right? I think I got 6. 1, 2, 3, 4, 5, 6. My dots are probably a little off. I apologize. I got 6. But who cares? Because what's 0 divided by any number? 0. So the slope of a horizontal line, guys, it will always be that answer. It don't matter where it is, what points they give you. This will always be his slope because every horizontal line will not have a rise. So it won't matter what his run is because his rise will always be 0. And 0 divided by any number is always 0. So he always has a 0 slope. All right, and then last, D. The vertical one, he's really a gray area because, yes, he's linear. His graph is a straight line. However, did we say that, is that a function? No, he doesn't pass the VLT. Guys, what's the only x coordinate that lives on a vertical line? Every single point has what x coordinate here? 3. This is the point 3, 0. This is the point 3, 1. This is the point 3, 2, 3, 3, 3, -1, 3, -2. Guys, if I asked you, when 3 goes into this function, who does he spit out? What would your answer be to that? Everything, infinity. He spits out every number. It's so not a function. So the verticals are always a little bit different. They are linear though. They follow all linear guidelines. We just can only call it a linear equation, a linear relationship. We can't call it a linear function though. Go ahead, Darren. So we're still going to be able to find his slope, but his slope is weird. It's not even a number. All right, here we go. If we found his slope, rise over run, change in y over change in x. I'm going to go from bottom point to top point. How many did you have to rise up to get to the next stop? I got 4. So up 4 would be +4. Over, how many did you have to move right or left? 0. There's no run on a vertical line. You don't move side to side. So he has no run. Uh-oh. Who's the one number in math you ain't allowed to divide by? 0. When you divide by 0, it's called something. It starts with a U. It's an undefined operation. You are not allowed to divide by 0 and get a definable answer to that. So guys, his slope is always the word undefined. He is an undefined number. There's no number we could say his slope is that is definable. So the way I remember it, all right, I remember this by my 3 U's. My first U is that a vertical line always goes straight up and straight down.
Marty?
Yes.
Um,
So that's my first U, up and
you
down.
have to do all that and give like the slope, or can we, like, if you don't know, can you just say it's undefined?
Yeah, if you know, I wouldn't even go through it. If I see a vertical line, I'm saying undefined. Don't put any work into it. If I see a horizontal line, 0. Don't even put any work into it. Undefined, this word. All right, so your 3 U's. The way I remember all of this about my vertical line is I know the line goes straight up and down. I know the 0 is underneath the fraction bar. And I know his slope is the word undefined. So those are my 3 U's. The line goes up and down, the 0 is under the fraction bar, and the slope is undefined. Okay, so guys, now you should notice that when the slope was positive, what did the line do? It was rising. It was a slanting line to the right. When the slope was negative, what did the line do? It falls, it decreases, right? And then when the slope was 0, it was horizontal. And when the slope was undefined, it was vertical. So you should remember all that. We're going to write it on our next pair of our notes. But they give you all kinds of tricks. Somebody last class showed me this, and I'd never heard of this. They remember it like this. When the 0's on bottom, that's no, that's not okay, that's undefined. And when the 0 is on top, that's okay. That is 0. And then, guys, this is fairly new. I don't really get how you remember all this. But a couple years ago, somebody showed me Slope Guy. He's like on YouTube. Slope Guy is one eye is a positive, and his eyebrow goes like that. That's what positive lines do. One eye is negative, and his eyebrow goes like that because that's what negative sloping lines do. His nose is a vertical line, and it's undefined. And then his smile has dimples.
Wow.
How do you remember all that? I don't know, but that's like Slope Guy. So his horizontal is 0s, vertical is undefined, and then positive goes.
Can't we just look at it and test where it goes?
I don't know. I always remember positive is rising, negative is falling, and then my up and down is my undefined, which makes my 0 my flat. I don't know. All right, but just whatever you gotta do to remember that. Okay. So here we go. Oh wait, you know what? No, I'll write this down first. Oh, I hate red because it doesn't erase them. Shut up, I know. I'm gonna be high all day. Probably shouldn't say that. Okay, so let's write it down. We got a rising line, which means his slope will definitely be positive. So guys, if you're graphing a line next week and it had a positive slope, but for some reason it went left, it was falling, you should catch that mistake. Go, wait a minute, this is a positive slope. Why does my line look like that? You know a positive sloping line has to go up to the right. It has to rise. And you can catch your mistakes. All right, we have a falling line, so his slope has to be negative. Okay, we have a horizontal line, so his slope has to be 0, flat, no rise. And then you have a vertical line, which goes straight up and down, so his slope is undefined. And guys, if you don't put 0 as the answer, like if you put 0 over 4, Delta Math marks you wrong. If you don't put the word undefined, if you put 7 over 0, you get marked wrong. I'm pretty sure Delta Math actually has an undefined button that you click as your answer if you get an undefined slope. All right, now before we do the last couple examples, we're not going to do all of them. But guys, before we do that, can I just show you Delta Math so that everybody understands what part of your homework is going to look like? Okay. So guys, they're going to give you a problem, and it says, draw a line representing the rise and a line representing the run. State the slope of the line. So guys, if you don't draw those little up and over or down and over lines, Delta Math is going to mark you wrong. And I have to understand that I'm pretty bad with technology, so this gave me a little run for my money yesterday because I kept double clicking and you're not supposed to double click. So guys, on your homework, and this is my only gripe, guys, they didn't give you dots, and that pisses me off because you need to use perfect points. Like, can you guys see this point right here? Clearly it's -6, but look at his y coordinate. It's like in the middle. Don't use that dot, please. Make sure you get one that like, oh, meets right at the corner. It's a great dot. Whereas this, oh, that's a nice dot. No, yes. Don't use bad dots. I wish they put them on there for you, but they didn't. Now that you see some good dots, now you're going to have to pick 2 of them and draw the lines. So you'd have to go up, looks like 1, and then right, it looks like 4. If you don't draw those lines, it'll mark you wrong. So watch how you draw the lines. So can you guys see that as soon as I go on this graph, there's like, where's my mouse? That little orange dot, can you see that?
Yeah.
All right, so go to your first point. Where did I say it was? Right there. Click on it. As soon as you click on it, it goes dark, and then you get a line. So drag it to where you want. I only wanted to go up 1, and then click. And then now you have this orange dotted line that's locked in. Then we're going to go to this corner. We're going to click. It gets dark again, and now you have your other lines. Then you're going to drag it over to your next one, click, and there it is. If you don't do that though, if you just count it in your head, it'll mark you wrong. And then you'll go and put your slope in. What did we do? We went up 1, so my rise is 1, and I went right 4. 1/4 doesn't divide, doesn't reduce. Hit enter, and you'll get your green check. Good job. Thank you. I'm telling you, yesterday I kept double clicking. I think if you want to get rid of the lines, then you double click. But I was like double clicking, and then this line was here, and then that one. Whew, but it's really not that bad.
I'm not comprehending it.
You're not? Why are you on there? I'm not done with our notes.
I know, but I was trying to figure out.
Sorry.
What you said, no, because it makes me-
Yes.
My mom's called me for 3 times. I don't think
Oh,
it's
hurry up. Hope everything's okay.
me too.
All right, so let's just do a couple of these next examples, and then I'm going to stop. Where's my notes? There. Okay. So guys, on your homework, if they don't give you the graph and you have to count the spaces, then they're going to say, hey, here are 2 points that you could connect to draw a line, but we don't want to waste time drawing it. You can calculate it just using its points. All right, so if we had to find the slope of a line that passes through the given points and describe the slant. So guys, let's find the slope of a line that connects these 2 points. I know that my slope is rise over run. That's y over x, right? So we're going to find the change in the y coordinates. You okay?
Yes.
Compared to the change in your x coordinates. Let's do it. All right, so slope will equal change in y over change in x. I feel like you've been trained to start with the second point and subtract to the first point. I don't know. I feel like Algebra 1 always does that with you guys. So I'm going to take the second y coordinate, which is who? 1. And I'm going to find the change. So I'm going to use what operation? Subtraction. And I'm going to subtract the first y coordinate, which is who? -2. So guys, you're going to get a lot of subtracting negative numbers. It's fine. What does subtracting -2 turn to? Plus, super plus. Over. Now we have to find the change in x. So in the same order, we're going to start with the second x coordinate, which is who? 1. We're going to find the change. So we're going to use what operation? Subtraction. Thank you, Kyla. And then who's the first x coordinate? -3. So again, what happens to subtracting a -3? Turns to plus. So in the end of the day, we get 1 plus 2 on top is 3. That's the change in your y coordinates. And then we're going to get 1 plus 3 is 4. That's the change in your x coordinates. And then guys, at the end of the day, it's a fraction. So make sure you reduce it. But lucky for us, it doesn't. So guys, this means for every 3 spaces that this graph goes up, it's going to go to the right 4. So it's moving side to side a smidge faster than it's moving up or down, but not much. So it's probably not too steep of a line. All right, but guys, if his slope is positive, describe the slant. Is it rising, falling, horizontal, or vertical? Positive, it's rising, so just give me that. That's how you describe the slant. Just show me the way it's gonna lean.
How did you do the math though?
Change in y over change in x. I took the second y coordinate and I subtracted the first y coordinate. Then I found the change in x by taking the second x and subtracting the first x. I feel like that's how they train you in Algebra
You
1.
have to do it like that.
No, you could do, I said you could do -2, subtract 1, watch this, -2, subtract 1, over -3, subtract 1. -3 over -4 reduces to who? It's the exact same answer. Go in any order you want. All right, here we go. Let's find the slope of the line that connects these 2 points. All right, change in y over change in x. So I'm going to take the second y coordinate, which is who? 5. I'm going to find the change, so I'm going to use what operation? Subtract. Who's the first y coordinate? -3. So negative negative turns to big plus. Over. Now the change in x in the same order. So I'm going to get the second x coordinate, which is who? I'm going to find the change, so I'm going to use subtraction. And now who's the first x coordinate? Just 1. So he's not a double negative. He's good. All right, so what's 5 plus 3 on top? 8 over -3, subtract 1. -4. So guys, that's his slope. For every 8 he goes up, he goes to the left 4. So he's climbing up twice as fast as he's moving side to side. That's going to be a pretty steep line. All right, but guys, we got to reduce it. Who's 8 divided by -4? -2. So you might say this, but I don't know if Delta Math is going to consider that simplified. So your safest answer is probably just -2. And now if his slope is negative, is he rising, falling, horizontal, or vertical? Falling. So his line should look something like that. Okay, guys, I'm going to do one more because I have 5 minutes and nobody should be packed up because that would be beyond rude, beyond rude. All right, if I do this one, change in y over change in x. -4, I'm going to find the change, so subtract, who's the next y coordinate? 7, beautiful, over change in x. I'm going to start in the same order, so I'm going to grab the second x, which is, I'm going to find the change, and then who's the first x? Ooh, -5. Guys, the x's were the same. If you subtract a number from himself, what's the answer always going to be? 0. So you get -11 over 0, which has a final answer of undefined. You click the button. And then does anybody know what the line looks like if it has an undefined slope? Up and down, vertical.
Oh my God.
Okay, so the other ones are just more practice, and then you're going to have questions like that on your homework. Are we okay? Slope is okay?
No.
Yo, come on. You don't hate it. The biggest thing is people putting X's on top. Don't put X on top. It's X, Y over X.
You say hate to say it's good.
But this is what gets me even more mad.
You know what?